our class for Hello everyone, welcome to our class for FTC programming using VRS, which is basically virtual robot simulator. So we are FTC team 2229 quality control. I'm Tara and we also have Latian here with us. So today's agenda, first we're gonna go over like what is FTC and introduce VRS, and then we're also gonna go over the FTC Ultimate Goal season game, which is basically the game that we're gonna be working with in the simulator. And then we're gonna have some basic lessons for working with VRS. Okay, so first of all, what is FTC? So FTC stands for First Tech Challenge, and it is basically a robotics competition for middle and high schoolers. So first and foremost, it's fun, and you also get to build and program robots, and it goes all the way up to a world's level. Okay, so VRS is Virtual Robot Simulator, and you can access it at this link, which Lutan posted in the chat. So VRS is a FTC blocks and on-bot Java simulator, and right now it supports for Ultimate Goal, Freight Frenzy, and Power Play season for those games, which are basically past FTC seasons. So for today, we're only going to be using block coding, and VRS is also very much a work in progress, so it's still being developed. So as I mentioned earlier, we're going to be in VRS, we're going to be working with the Ultimate Goal FTC season. So in this simulator, we're going to simulate Ultimate Goal. So we should obviously first get to understand the Ultimate Goal game a bit. So this is the season game introduction for the Ultimate Goal season. Wait. Sorry, I need to,
you might need to reshare and then mark the share sound.
Wait, let me know if you can hear this.
No, we cannot. Oh, we can.
Welcome to the First Tech Challenge 2020-2021 season game, Ultimate Goal, presented by Qualcomm. Part of the first Game Changers season, powered by Star Wars Force for Change. A team consists of up to 2 driver operators, a coach, a human player, and a robot. The robot must be built from materials specified in the game manual and fit within an 18-inch sizing tool, but may expand after the match begins. Each match is played with 4 randomly selected teams, 2 per alliance. Each alliance is allowed only 1 human player. Your opponents for one match may be your partners for another. The game is played on a 12-foot square playing field with a foam tile floor and 1-foot-high walls. 5 unique navigation images are located around the field perimeter. At one end are 2 tower goals, each containing 3 alliance-specific goals with return racks. Between the 2 tower goals are 3 red and 3 blue power shot targets. There are 2 red and 2 blue taped start lines, and 3 red and 3 blue target zone goals. Red and blue tape squares indicate starter stack locations, and a white launch line divides the field. Outside of the field walls are the 2 alliance stations and 2 human player stations. The primary game element is a ring, approximately 5 inches in diameter and 3/4 of an inch thick. A match is played with 20 rings. There are 2 red and 2 blue wobble goals. These can have rings scored onto them and can be moved for additional scoring. Before each match, teams place their robots on the field, touching the front wall and over one of their alliance's starting lines. Each robot must be touching or be in possession of a wobble goal. A robot may possess or touch up to 3 rings. After the robots are in position, field personnel will randomize the starter stacks into one of 3 configurations. This determines which target zone goal is active in the autonomous period. 0, 1, or 4 rings correspond to target zone goals A, B, or C, respectively. Unused rings are stored in the human player stations to be deployed to the field at the start of the driver-controlled period. The players and field are ready. Each match begins with a 30-second autonomous period. During this period, there are a number of ways for teams to score using only pre-programmed instructions and sensor inputs. Delivering a wobble goal to the correct target zone earns the Alliance 15 points. A robot parked over the launch line earns 5 points. Each ring launched or placed into the low goal earns 3 points. A ring launched into the mid goal earns 6 points, and launching into the high goal earns 12 points. Robots earn 15 points for each power shot target knocked down. Robots must be completely within the launch zone to launch rings into the mid goal, high goal, or power shot targets. Following the autonomous period is the 2-minute driver-controlled period. During the driver-controlled period, human players are expected to return rings to the playing field, as well as reset power shot targets. Each ring launched or placed into the low goal earns 2 points. A ring launched into the mid goal earns 4 points. However, rings launched into the opposing alliance's goal earn points for their alliance.
Okay, so I'm going to stop there for now, but I hope that gives you an idea of how the Ultimate Goal game works. Okay, so now we're going to go to therobotsim.online, which everybody should already be at. So the first thing on the homepage, it shows programming, so that's what we're going to choose. And this brings us to the simulator. So immediately when you enter, there should be a little, yay, welcome to the simulator thing that pops up. So we're gonna go through the text guide real quick. Okay, so on the bottom right here is our simulated game field. So this is the game field for the Ultimate Goal field that you guys just saw in that video. And then on the top here are the controls where you can start and stop your program. So when you initialize, that resets the field and then you can run your robot. So initialize, the field resets, and then start program. So as you can see, the robot moves, yay. And then on the left here is our programming interface where we use block coding to make the robot do stuff. So it's going to break down this code a bit. So here is where we initialize or start the robot, and that involves telling the motors to spin a certain direction. So on a car, in order to propel the car forward, one side's wheels are going to be turning clockwise and the other side's wheels are turning counterclockwise. But here, all our motors by default turn counterclockwise. So we need to tell one side's wheels to turn the other way in order for all the wheels to be turning forward. I hope that makes sense. But if you have any questions, just feel free to ask in the chat or you can turn on your mic. So, and then here, we're going to skip this step since we're not using it today, but you can always go back and look into it later. So here is where we get the robot to actually move. So we set the power of the front motors to 1, and then here we sleep or wait a bit for the motors to actually run for 1000 milliseconds, which is 1 second. And then we set the power to 0, so we stop the robot. And now this is the telemetry box, which basically displays data that lets you know what part of the code is running. So here add data says what to put in the box, and then update basically just updates the box to display what you tell it to display. So yeah, it's just helpful to know which part of the code is running. Okay, so we are going to skip the rest of the tutorial since we're going to go over it ourselves with our own lessons. Okay, so, oops. Your first mission is getting the robot to drive over to the white line, as you can see on the right here, and then stop over it. So as a hint, you just need to edit the sleep function. So yeah, everyone should try and do that on their own. And I'll give a couple minutes for you to do that.
Yeah, we'll be editing the default program, which you can find by in the dropdown just selecting load program, or you could go into new program and select a new autonomous. It's the same thing.
Yeah. Again, if you have any questions, feel free to put it in the chat or just turn on your mic and ask.
Can you go on to the lesson slide?
By the way, although this is a simulator, but actually if you have the real robot, this will be the exact same program code you can run. This block code, you will run the exact same code, exact same language there to actually drive the real robot.
Does anyone need more time for this?
Okay, so moving on. This is the solution. Your code should look something like this, where we just increase the time. So let's run this. So yeah, as you can see here, I just changed it to 3000 milliseconds, which is 3 seconds. So I'm gonna go over here and initialize and then start. Yeah, so as you can see, it just stopped over the white line. And also when you're done, you should save your, you can save your program as whatever you want to call it. You can just go up here and do save as. Yeah. Okay, so you might have noticed, but this program is only using 2 of its 4 motors. So here we're going to try changing the code to use 4 motors to drive to the white line instead. So the set power, here you can see how we set the power of different motors. These blocks can be found in actuators here on the left, and then DC motor. And so as you can see, there's dual and then there's quad. So quad is setting the power for 4 motors instead of 1. So now you're going to try change the code to set the power for 4 motors, and then, but again, you want it to drive over to the white line and then stop over it.
As a quick tip here, if you hold control while you drag a block, you only move that one block instead of everything under it.
Yeah, normally you would move everything under it. You can just drag one individually. So I'm going to give a couple minutes for everyone to try doing that.
Can everyone open the website and create the program successfully? Anybody hit any issues like loading issue, any problems?
When I try to drag a block, it literally just scrolls the whole program around.
Yeah, if you hold control while you grab that block, it's only going to select the one thing.
No, like
Yes.
even when I let go of the mouse, it just scrolls it around.
Oh, try right clicking or try, you might need to reload your page.
Okay, so I'm going to move on now. So yeah, basically we just needed to replace the 2 motor blocks with new 4 motor blocks. And your code should look something like this. So it's basically just the original one, but we're setting the power for all 4 motors instead of just 2. And then we also have to change the sleep block since there's 4 motors now. So it's obviously going to be moving faster. So we need to set the sleep to about half. Okay. So let's try running this program. Initialize. So as you can see, it resets the field, and then I'll start. Yeah. So again, what we did is, so we just throw this in the trash and throw this in the trash. And then we select a quad block for set power. Oops. And then we replace, and we put those where the original set power blocks were. And as you can see, we're still keeping the telemetry block. So when we run this program, it's going to tell us, it's going to tell us that we're driving forward. And again, remember, we have to set the sleep to about half. Okay. So next, what we're going to try and do is drive forwards and back. So yeah, what you should all try doing is basically just get the robot to drive backwards to its original starting point. And I'll give some time for everyone to do that. And remember to change the telemetry block when you're driving backward.
So for this step, we will move forwards and then we'll move backwards.
Yeah.
You will, as a hint, need another sleep block, which you can get by copying it or in the brown tab on the left.
Okay, so your code should look something like this, where we basically, so again, we drive forward and then sleep a bit, and then we set the power to -1. So we drive backwards. And again, remember to change the telemetry box to show that we're driving backwards. And then we sleep a bit, so to wait for it to actually run and go backwards. And then we set the power to 0. So I'll go through that again. So basically, we need another set power block, but we set it to -1. And just like earlier, we need to add a telemetry box. I'll just copy it because I'm lazy. So we have it update the telemetry box to say driving backward. We sleep a bit and then we set the power to 0. So let's try this out. Yeah. Okay, does anyone have any questions? Okay, so next we're gonna try strafing right. So this robot actually has these special wheels called mechanism wheels, which allow the robot to strafe. So if we reverse opposite corners of wheels, for example, we have top right wheel, the top right motor and the bottom left motor, then the robot is going to strafe. So I'll demonstrate that. So, oops, okay. We need 4-wheel motors. So if we set the front left motor to -1 and the back right motor to -1, and then it's going to strafe left, as you can see here. I'll do that again. It strafes left. So I'll also update the telemetry box to say driving left. So your mission is to make the robot strafe right. And I'll give a little time for that. Okay, so here is what your code should look like. Basically, we set the front right motor and the back left motor to -1, but we keep the other 2 motors as 1. So this, and as you can see, I've updated the telemetry box to say driving right. So now the robot is going to strafe right, as you can see. So now Latian is going to take over. So I will stop sharing.
Okay, thank you, Tara. I'm going to handle the, oh, there was a question I missed in the chat. Never mind, that's me. Where were we? Right, we just successfully made the robot drive forwards, drive backwards, and strafe right. And we can notice that there's like 1, 2, 3, 4, 5 blocks that are involved in that long task. And if we want to do some complex motions, like say, for example, driving in a square, because we want to for some strange reason, then we're gonna need 1, 2, 3, 4, 5. We're gonna need like 25 blocks for that, and that's not very like clean if we just stuff everything onto the left over here. So there's something, those of you that done Scratch or code.org might be familiar with, is functions. So functions are like neat little packages where we can basically put code in there, and all we do is call the name of that function. So we don't need to copy it a lot of times. So for example, if I drag that strafe right that we just did, the drive right that we did, I can come into the function section and actually, yeah, I forgot. We can also put inputs into this function and tell it like when we want to do something with it, we're gonna have a custom input for it. And if we stick it here, now this is basically a big package where we can repeatedly call this one thing multiple times without needing all 5 of these blocks. So I can do something like this, wait, and then this again. And that would be really that will make it much easier for us to code in when we start doing more complex tasks. So here I nudge twice over without needing all of these blocks down in this area. So what we're going to do now, this task is to basically clean it up and put all of the different motions that we've generated so far into functions. So drive forwards, drive backwards, drive left, drive right. You do not need to do the turns. And that will and then we're going to use those functions and make the robot drive in a square here. To make it much faster to code, finish one of the functions and then copy that function and rename them and edit them appropriately. How's it going? Does anyone need more time? I think we're, does anyone need more time? I think we're all done.
Yeah,
We
some
should be done.
people need some more time in the chat.
Okay.
Someone said it is not initializing when I click the initialize button.
Like, what do you mean by doesn't show, is not initializing? Does it show the start program button?
It says program, yeah, it shows start program and it also says program initialized, but the program stays where it previously was.
Yeah, you need to press initialize, and then when you press start, it runs the code.
No, like when I press initialize though, it doesn't send the robot to the start.
Oh, try clicking the reset field before you initialize. See if that helps.
Okay, yeah, that fixed it, thanks.
How do you do the with time thing? Can you clarify what time thing you're talking about?
Like in my code, it just says straightforward and then it goes to the next like strafe right. But yours said like strafe left with time and stuff.
Oh, so if you to add inputs in programming, it's called arguments or parameters. You hit that gear icon on that function, and it'll pop up like a little window where you can just drag in inputs that you need, and it puts it there. We'll be using one input called time. If you want to, you can also add another input called power, but we do not require that. Make sure the gear you're clicking is for the function you made. So drive forward, drive left, not the run op mode, because that one will not show anything when you click that gear. Did that answer your question, Nathan? What is
How do I make a new function?
to make a new function? On the left, there's the what color would you call that, Tara? Pinkish purple? It's called functions, whatever. You can drag that out and like it's the first one, and then you can name it something in the text box here. And Zachary asks, what is the difference of functions and no functions? So let me just show you like hypothetically what it would look like for a square program. Like here, it's really obvious. You drive forwards, then right, then backwards, then left. If we don't use this, just toss all this in the trash. We drive forwards.
Wait, they meant inputs and no
Oh,
inputs.
okay. Inputs and no inputs. So the reason we have an input is because we want to be able to control like how long the robot will drive forwards for. Because if it always goes forwards by 1 second, then it's going to be like, then we have to still manually do the like half a second or smaller amounts. So by having that input there, we're able to like control how much sleep is in there. You do need to drag the variable that you made here. So the input name is time. You have to go to the variable section on the left and dragging that time block and replace the milliseconds with that time variable, like over here. For those of you that are done, you can try to add another input called power, and then put that power into the first set power block so you can control how quickly the robot will move. Use the math negative sign if you need to make it negative. Does anyone need more time? Or is anyone stuck? Since no one's saying anything, I'm going to assume that we're all done with this step. So the solution for this is basically we have kind of like a format where we first set the motor powers to what we need. For drive force, it's all 1. For drive right, the front right and back left are negative, and accordingly with the drive left and drive backwards. And then we call the telemetry and tell it which direction it's driving and update that in the telemetry box. So when we run a program, it tells us it's going right, backwards, and then left. And then we sleep for the variable time, which is what we set as an input earlier for each of the functions. So that allows us to differ like how big that square we want, how big we want the square to be. So if right now I have it all set to 1 second. If I set them to half a second, they will go in a much smaller square. Nice, I got a wobble on the robot. And then we finally turned the motors off, and yeah. Does not have to set power to 0, and reason is that's fine is because when you have 0, if you don't have this, the next call is set power to 1 or something else, and it overrides that 0 anyways. However, the reason we have the 0 is for the edge case where it's the last program on it, or we want the robot to stop after we do something. So maybe if you just randomly, if you add a wait after this and you don't set it to 0, it's gonna go all the way. It's gonna keep on moving that motor, so it's gonna crash. So we have it there to stop the robot in that very edge case. So it stops here. Basically, our function turned the motors on. We don't want to leave them on. We want to turn it off again. And then when we call the functions, we come over here, drive our function blocks, and then put our input in here, which is under the math section. We put the number there, and then we can edit that number and tell it how much we want it to go. You might also have noticed that these two blocks look pretty different. One is like one line and the other one is like thicker. We can, to make it look a little bit cleaner, you can right click the blocks and inline inputs. This is just an aesthetic change. It doesn't change any functionality. Does anyone have any questions?
Someone asked, why do you need to set power again after the call?
I already answered that, but
Oh,
it's
okay.
basically, so we turn the motors on, we want to turn them off again. So that when we like, for instance, just sleep after our last block, the robot is not gonna move. Okay. We'll be using these blocks for the more complex tasks that we're going to go into soon. And you may have been wondering, when will we actually shoot those rings that are on the robot? We can do that now. So to shoot the robot, not shoot the robot, to shoot the rings, we need to first position the robot so that it's in front of the goal, so it can actually shoot into that target there, right? And so we will be leveraging our move functions that we just created, the move force and the strafing, to put ourselves right there. And to actually shoot the rings, there are two of new motors. We've already worked with all the drive motors, front left, front right, back left, back right, but there are two motors that have to deal with shooting the ring out. And that's the ring flywheel, which are the two giant green wheels you see like on the front of the robot that are like touching the rings. And because those are gonna spin, they're going to shoot the ring out, and that's what it's simulating. To turn it on, go to the actuator section. On the left, DC motor, not quad because it's just a single motor, just hit the DC motor button and grab that set power block and find that motor in the drop down. And that's the ring flywheel. This will need some time to start up, so you should have a sleep function. Back. Okay, I think I broke my cursor. So you should use a sleep function like right after you call that set flywheel. Experiment with how much you need to wait for it to consistently shoot it out. And then even though the flywheel is on, we actually have to push the ring into the flywheel, so that gives us a lot more control over when we will shoot the rings. And that's a separate motor, again, that's called ring shooter. So when you set ring shooter's power to 1, it's going to start launching the rings every few milliseconds. Again, because it's a motor, you should sleep after so that it finishes all its tasks. So now with that like in the bag, I'll give you guys time to program the robot to position itself, turn on the flywheel, and then turn on the ring shooter and shoot all the 3 rings into the goal. As a hint, if you find that the wobble, the big disc round thingy on the ground is blocking your shots, wait a few seconds after you move forward so that you don't have forward momentum like sticking you to that wobble, and then strafe.
Wait, how do I get it to pick up the rings and shoot them again?
Pick up the rings is the next lesson that we'll be going into. But it is another motor. You can jump ahead for that.
Like, how do I use the other motor?
Which motor do you want? There,
Like the motor that's used to shoot.
the motor that's used for shoot is the ring flywheel, and that's the wheel that's spinning and pushing the ring forward and launching it. So when the wheel spins really quickly, if something touches it, it's also going to like get pushed along at that high speed. And that's the ring flywheel.
No, I mean, how do I make it shoot it?
Oh, after you start the flywheel, you need to turn on the ring shooter motor, which is a separate motor.
How do I start the flywheel?
In the actuator section, you can grab the set power block. It had defaults to front left, but you want to change the motor to the ring flywheel. And then do something similar for the ring shooter. So these things here.
The lag is making it impossible to take the block out.
Take the block out. What do you mean?
Like it's extremely laggy.
If there's a lot of lag, close other tabs and apps because they do impact the simulator. For this motor blocks, you want the set power block. So grab the set in the actuators DC motor, grab the set power. It defaults to set front left dot power to 1. Take that out, and then it'll There's a the first one has a drop down, which allows you to choose which motor you want to use. We'll be using the ring flywheel and then the ring shooter.
Now the edge window is frozen.
Did you save? Hoping.
No, I forgot.
Okay, I'll send you one of the versions in here. But restart Edge first. So in the chat, I just sent the solution version, which has solution for the square one, which has your drive forwards, drive left, drive right, and all of those. You can try to work with that. And just delete the hide code block. Inputs will make your life much easier for the functions.
Wait, but where does it ask to input?
If you press the gear icon when you make that in the function, then you can drag in inputs and name them.
No, I mean when you run the program, when does it ask to input?
When you run the program, like, so if let's just grab one from the left. Under functions, we can grab, I don't know, drive forwards. And then there's going to be a little like puzzle piece inlet thingy over here where you will where it asks for that input. And there you put your input right here. So you grab a math block, the number, and put it there. I recommend creating basically a copy paste palette. So you, when you're programming, you just copy it and drag it where you need to instead of going to the menus each time.
But when I run the program, isn't it like supposed to display a text box that asks me the thing that I put in the input?
For the functions, unfortunately, it doesn't have a text box like built in here. You will need to go to the math section and grab the corresponding block yourself.
I mean not like when I run the program, something asks me for the input.
That's probably because one of the functions doesn't have an input. Is that what happens? No. I don't understand, like, I've never heard of this before. Tara, can you take a look at the problem? Can you share your screen and Tara can take a look at it?
Oh, should I go into a breakout room?
You can do that. The person who had the issue, can you join the breakout room 1? And Tara can help you there.
Wait, how do I join it?
Um, okay, confused on how you move the flywheel and stuff. Can we please review that? So let me reshare my screen to share the obnoxious sound that sounds when the flywheel is active. Okay, so just going to remove all of this and then start here. So actuators, we can grab our motor, the set power block, and the flywheel. And the ring flywheel is the green thing. It's what will propel the ring forward. So we need to turn that on. I need the sleep block. So that's going to, so that's going to basically do this whirring noise, and that's what you hear when that motor's on. And then while that's on, we can shoot the rings forwards, basically push the rings into the flywheel, so then it picks up speed because the wheel's spinning so fast. So that's a separate motor called ring shooter. And then again, wait for it to fire. And then if I run this, here I turn on the flywheel, wait 5 seconds for it to turn on, and then turn on the shooter and start pushing the rings in and keep it on for 5 seconds and the program will end. So just gonna take a look at this. Flywheel is on, and then it starts shooting, and then it turns off. Did that answer your question? Does anyone need more time to get the rings into the goal? One more. Okay, we'll go to, how do I see the time on this computer? Wait, what? We'll go to I'll go to 315 and then we'll have to move on to the next step. Okay, it's 3:15. We'll have to move on to the next part, which is actually pretty similar to this one. But let's quickly go over the solution for this shooting problem. So the first one we do here is drive forwards. Here I have it set to 1 second, and then I stop the robot for 500 milliseconds. And the reason is we're pushing this wobble. Andrew, the class is 2 hours long, so we end at 4. Although I don't think we probably won't need all of it. But yeah. Yeah, so here I'm waiting 500 milliseconds just to make sure the robot is stopped when we move forward, so it doesn't have some forward momentum that messes with things. And then I drive to the right just a tiny bit so that we're positioned right in front of the goal. Then I turn on the flywheel and wait a second for it to start up, because if we actually start it immediately, then the flywheel is not at full speed, it's going to be weak, and the ring is just not going to be propelled out at the expected force. So I'm just going to actually set the power to 200 and just show you. So it's weak. That's why we wait a little bit more on that. Oops. Your numbers likely won't be exactly the same as mine are over here, because it kind of depends on how much latency your system has. But it should be relatively close. Okay, so now that we have shot all 3 of these rings, it's just 3 rings. There are actually more rings on the field, obviously. So it's not we see there's 4 rings like right there in the middle of the field on the blue tape right there. We can use the intake wheels, our ring collection wheels, to pick them up and then shoot them again for 4 more rings into the goal. And so that will be our next task. So to do that, we need to turn on the ring collection motor, just like how we turn on the outtake. We can get that set power and then in the drop down, find a ring collection and turn it on. And then we need to drive backwards into the rings so that we pick them up. If the ring stack that generates on the field is random. Sometimes it's going to be 0, sometimes it's going to be 1, sometimes it's going to be 4. We're going to assume that it's going to generate 4, and if you can't, if you don't want to like just keep on randomizing it until it shows up as 4, you can hit the 3 lines over here, like in the Unity simulator. In the left corner of that simulator, you can hit that button and then change the field setup to, I believe, C. And then start the program. It is not C. Maybe it's A. I am now confused. Please work. Should be C. It is C. Yeah, so change the field setup to C. And okay, so that's the thing that's working. Yeah, just change the field setup to C. Don't touch anything else in here other than the cam setup if you want to mess with that. But if you change it to always use field setup C, it will always generate those 4 rings for you. And then, yeah, so it should look something like this, this animation here. I'm not gonna pronounce the 3-letter word.
Lutian, we're back. So do you want to explain what is going on?
Yeah, so earlier we made the robot drive right in front of the goal, and then we used the flywheel and shooter to shoot the 3 rings on the robot into the goal. Now we are going to drive the robot backwards to pick up the 4 rings that are on the field and then shoot those into the goal as well. So to do that, we will be using the ring collection motor, just like how we did with the ring flywheel and the ring shooter. This motor will turn on the intake, and when we drive into the rings, it will put them into the robot.
What's the difference between a ring flywheel and the ring shooter?
The ring flywheel is a motor that needs to get started to propel the rings forwards. And then however we even if it's on, we want control over when we shoot it because the ring flywheel does take a bit to start up. We don't want to keep on spinning it up to high speed and then turning it off again. So we have another motor called ring shooter that will push rings into that flywheel. And so when the ring gets pushed into the really fast spinning wheel, it gets propelled forwards at high speed. So then we also have control over when we shoot it. So you will need both of them to shoot the rings. How's it going?
I can't find the other 3 rings. They don't exist.
If you can't find the rings, hit the in the bottom right, hit the 3 horizontal lines like next to that weird obnoxious green arrow, and then change the field setup to C, and then that will always generate for what the heck? Is this broken? Is this broken? Maybe it's broken. Hang on. I think it's broken. Never mind. Okay, I have a complaint to send them. Yeah, it's broken. You'll just have to basically keep hitting re-initialize and stop until you get the 4 rings, unfortunately. Does anyone have issues turning on the ring collection? Or is everyone just tuning the robot's positioning so that it shoots correctly? When you say different result, are you saying like the number of rings on a field? It's randomized, so it's unfortunately the way to like set it is currently broken.
No, like not the rings, like the result of the robot each time. Even if I have the same amount of rings, the result of the robot changes.
Oh, are you talking about the robot's positioning or like when you push that the wobble forwards, it like gets in the way?
Like each time it moves a different amount, even though I don't change the program at all.
I think that's a lag issue, unfortunately. To like help with lag, usually we close all the other tabs and apps. That is true. In FTC, the time is inaccurate because if the battery is low, then the motors aren't going to run as quickly. For the simulator, I think it's running Unity and it's doing something back there, and probably that's causing a lot of like variation. Usually when we
Depends on how many rings are out there.
say that again.
Like on a C mode, like the behind the goals, it just periodically shoots out rings.
Every now and then the rings go all the way through it, or what?
Something behind the goals that just shoots out rings.
Oh, are you talking about like the thing over here? Like the
Yeah, like
thing that-
each time.
Yeah,
it's
hang on. What's happening? Let me try running the program. Should be run- What happened to that thing? So like there's only 20 rings in gameplay, like in the driver control period, it spits out rings at you. And I think this is because we're currently on we messed with the game setup, so it started like thinking it's in driver practice. But if you change it to like auto, it's not gonna do that anymore. this is the last thing that we're doing. If we, in your free time, you guys can also like mess with hitting the 3 power shots right next to the goal. Those give you more points if you want to try and going for those. Let me, in my slide, I actually have it in here, but I really don't think we're gonna have time for that. Basically, it's just move in front of those 3 bars and then shooting them. It's not very reliable because as you saw, there is a tiny bit of variation between each run. Out of curiosity, I want to just simply
Just throws out rings every now and then. I should say so. Sometimes it literally misses the goal by by like a few inches, and then sometimes it goes right in.
yeah, it does that. Because like when it moves back, if it moves back too far, it then starts arcing a little too much. If I change the cam setup to 3, yes, we might be able to take a closer look at what's happening. It like gets dangerously close to the bottom of the goal. Yeah, it's like glancing off of it. You can go to PowerPlay. We do have a simulator for that. It's powerplay.vrobotsim.online. And I haven't played too much with it, but it does have this year's game in it. It has a few more features, but and we're experimenting with like robot importing. Does everyone have their thing like work pretty well? You guys can challenge yourselves to like score as many points as possible in autonomous 30 seconds. And you can also like play with moving the wobbles around. I'm actually not sure exactly how to do that with this robot, but it should be possible if you just assume that it's always in the far corner. Well, yeah, so this is the power play. This is this year's game. I can't drive. Grab this. There we go. Sure. No. I'm playing this with my keyboard, so come on. I missed. Come on. A little bit. Yeah, there we go. How do I drop this? Which button is it? How do I drop this thing? Well, that scared me. Okay, I'll put the PowerPoint one in the chat as well. If you want to mess with it. Yeah, how is everyone doing on the reload part? We have 15 minutes left in the class, and we're probably not going to go into power shots. How are you guys doing? Should I go over the solution for the shooting thing, the reload thing? Okay, I'll just go over the solution then. So we have, oops, we have all of our functions over here. We're just using them as usual to make our programming much easier. The first thing we do is position the robot, which is done with a forwards and then a strafe. Let me set up the camera. So the first thing we do is move forwards and then strafe the robot to the right. I have a little wait in here for the momentum to stop. This is the same as the previous lesson. Everything at the start is the same. Turn on the flywheel, wait for it to reach the max speed, and then start shooting. And then to start collecting, I turn off the shooter. You probably do not need to do this. And then I turn on the collection motor, so that way any rings we touch in the back will go into the robot. I have a sleep here just so it's similar to the others. I don't think we need it. And then I drive backwards for 500 milliseconds, so not super far away. So I pick up all of the rings, but also don't get out of range of the goal. Because if you go too far back, then the shots get dangerously low. And then I start the shooter again and let it shoot all of the rings there. Then at the end, I actually have a parking to move forwards onto the line just for the final 5 points. Does anyone have questions? Okay then, I think we're going to wrap off then. Do I have any more slides? I do not have any more slides. Yeah, so that'll be the end of our class. You can continue using the simulator and try to score for more points. If you if you're in an FTC team and you also want to share this, you can do so. There's the power play simulator. If you find bugs there, please report it to us on the Discord or email it or just let us know. and we'll try to fix them. Thank you all for attending. Yes, we do have Discord. I'm one of the developers on it. There's there are a couple other teams also working on it as well. One of the features that we're working on is importing custom robots. So basically you have Fusion. Is this done yet? You have Fusion, you build a robot in Fusion, you take a plugin and then you export it and set it up. It's pretty cool. And yeah, I think that'll be it all from me. Thank you for attending and good luck on your programming journeys.
If you have any questions, send an email to us. The FTC 21229 Gmail.
Yeah, thank you all for coming.
Bye.
Bye.